Hello class, welcome to today's lesson, which is a continuation of the previous class in which we talked about the method of completing the perfect square trinomial, also known as the method of completing the square. So we stopped, if you remember, we stopped at equations 3 and 4, and for this particular lesson I have also added a new one, okay, equation number 5. So let's go right down to the work. Equation number 3. Here we go. It's a quadratic equation. It's not in standard form. So remember that that's the first thing we have to do. Put this equation in standard form. There you go. Done. Second step, make sure that the coefficient of the quadratic term, which is this, is equal to 1. And if it's not, what you're going to do is, an operation, a valid operation in order to transform it to 1. And we know that such valid operation would be dividing both sides of the equation over 3, because that's a valid step, and then divide each of these three terms over 3. We get 3x squared over 3, we get x squared, and thus we have achieved our goal. And then the other two, minus x over 3. You can actually write this, that would be perfectly okay, but I would advise you to write it in this way. Minus 1/3 of x, which is also the same, right? Keep it this way. Keep the coefficient of x to the left of x. Okay, that's a much better idea. And then plus 9 over 3, you get plus 3. I made a mistake. I'm just realizing this 9 should have been negative, right? When I bring it to the left side. I'm sorry about that. I hope you have caught that. There you go. Now it's correct. Equals 0. So, okay, at this point, I have already made sure that the coefficient of x squared is 1. Let's continue. Now, bring the constant term, which is minus 3, to the other side. There you go. This is the third step. And then the next step is singling out the coefficient of the x, which is all of this, minus 1/3. You're going to bring it some other place, preferably, and you're going to do a series of changes on this. First, you're going to divide it over 2. Make sure that what you're going to get is minus 1/6. Okay? And then, minus 1/6, you're going to raise it to the square. So you're going to get minus 1/6 to the square. And I told you, at this point, you're going to leave this number as it is. You're not going to calculate the 1/6 to the square, which is going to be equal to this. Okay, minus 1/6 to the square is going to be equal to this, but I don't want you to represent it in this way. I don't want you to do that. The only thing you're going to do when the number is negative, like in this case, what you're going to do is make it positive, like so. 1/6 to the square. Why am I allowed to do this? Why is this equal to this? Well, because it's the same, right? Minus 2 to the square is equal to its positive to the square, right? Minus 2 to the square is 4, 2 to the square is 4. So I'm perfectly okay if I do this type of change. Minus 1/6 converted to 1/6 because it's in fact the same thing. Okay. Let's continue. Now that I have achieved all of these transformations, I end up with this number, and that's the number that I'm going to add in both sides of the equation. Okay, plus 1/6 to the square equals 3 plus 1/6 to the square. Because at this point, when I do so, when I add this particular number to both sides of the equation, then this trinomial becomes a perfect square trinomial, and thus I can write it as a binomial to the square. A binomial to the square will be equal to all of this. What's going to be the binomial? This number will always be x. This number in here will be this one in between parentheses. And the sign of the binomial, this sign in the middle, whether minus or plus, how are you going to choose it? It's going to be the same as the sign in the linear term. It's going to be, in this case, minus. There you go. Equals all of this. And this operation, you can perform it, okay? You can pick up your calculator, that's fine. And you're going to have 39 over 36. Do not, I mean, my calculator gives me this, 3 integers and 1 36. I'm sorry, it's not 39, it's 37. No. I'm getting confused. Give me a moment. Now it's actually 109 over 36. Let me confirm that. I don't want to. Yes, that's right. It's 109 over 36. But listen, what I was gonna tell you is this: my calculator gives me, when I perform this in the calculator, okay, when I enter that number, my calculator gives me as result this mixed number, 3 integers and 1 over 36, which is the same as this, right? But usually in mathematics, we never use mixed numbers like this. Never. We either use proper or improper fractions. Remember that this is an improper fraction. Use improper fractions. That's much better. Do not use these types of numbers when you are dealing with equations. Okay, fine. So we have this, and at this point you know what to do, right? When we have a binomial to the square equals some other number, all we have to do next is take the square root in both sides of the equation. So let's do it. First, I'm going to express what I'm about to do, like so, and then I do it. So the square root takes away the square. We get this equals plus and minus the square root of 109 over 36. We can leave this number as it is because it's not easy to calculate its square root. And well, I'm going to continue here. Finally, we isolate the x. X will be equal to plus minus the square root of 109 over 36 plus 1 over 6. And what does this mean? Remember, that means that one of your solutions goes with the plus. So your first solution would be, in fact, this. Okay? And the second solution, x2, will be equal to negative the square root of 109 over 36 plus 1 over 6. These are my two solutions, one with the plus, one with the minus, and I'm done. I have to erase this. Okay, so that's the first, well, that's the third equation. Now let's go directly to the number 4. We have this, okay. Let's put it in the standard form. It's gonna look like so. Okay, perfect. Second step, make sure to have the x squared with a coefficient of 1. So let's divide all the equation by 4. I'm going to do it directly, okay? I'm going to save that step. This is what you're going to get when you divide over 4. Next step, bring the constant term to the other side of the equation. There you go. Next step, single out the coefficient of the x, which is plus 1 in this case. You don't see the 1, but it's over there, plus 1. Bring it here and do the series of steps. Divide it over 2, you get 1/2, right? And then raise this number to the square, so you get 1/2 to the square. And that's the end of this process. I end up with this number, 1/2 to the square. And that's going to be the number that I'm going to add in both sides of my equation at this point. Minus 4 plus 1/2 to the square. Okay, by doing so, by adding this number in both sides of the equation, this becomes a perfect square trinomial, and thus I can write it as a binomial to the square. The first term will always be x, the second term will be this number in between parentheses, and the sign will be the sign of the linear term, in this case plus. On the right side, I perform this operation, and you will get, it's gonna be minus 4 plus 1/4. Minus 4, how many fourths is in here? Minus 16 over 4, right? Plus 1/4, it's gonna be minus 15 over 4. Make sure all of this is equal to minus 15 over 4. Make sure. Don't believe me, make sure. Okay, so, well, let me write the minus in here. Minus. Okay, so at this point, we can actually stop the process, right, guys? Can you see why? What's going to be the conclusion for this equation? Look at this. Look at what we have. Never lose sight of what you're doing. Look at this. We are trying to solve an equation in which we have a number, which is all of this, to the square equal to a negative number. Can we actually solve this equation? No. No, because there is no number such that when we raise it to the square, I can have a negative result. So my conclusion is immediate. I don't even have to do anything else. My conclusion is there are no solutions. And you can write the reason, right? Because any number to the square will produce a positive number, and we're trying to solve an impossible equation. You know, you don't have to, but be aware that that's what's happening, okay? No solutions. Okay, and finally, just a little bonus in here. You may be asking, okay, what's going to happen when my equation, even though it's a quadratic equation, is not complete? Okay, like in this case, this is not a complete quadratic equation because it's lacking its constant term, right? So can we still apply the method of completing the square? Yes, you can, but it would be pointless. Okay, like don't do it. Don't do it. Yes, you can, but there is no advantage in that. You can always solve this type of equation very quickly by factorizing. Remember, take an x as common factor and then factorize. For x plus 9 equals 0, you see? All of this is equal to all of this. And thus, you can apply the method of factorization because you have actually factorized. Now you just go like this. This means that either x is equal to 0, the first number, or the other factor, or 4x plus 9, is equal to 0, and you solve each of these equations. This is already solved. You solve this one, and you're done. And the same goes if you had any other equation, for example, what about lacking the term in the middle? What about this? Now the term that you're lacking is the linear term, you see? The term with x. Can you still apply the method of completing the square? Yes, but it would be pointless too, because this equation can be solved very easily by just doing this, you see? And then this, you see? And then taking the square root in both sides. That's it. You see, so there is no point of applying the method of completing the square with these types of equations, only when your equation is a complete quadratic equation. Okay, guys, so I'm gonna stop it right there. I'm gonna tell you in the post what exercises you're gonna perform today in the asynchronous class today, and in the asynchronous class for tomorrow. And that concludes the method of completing the square. Any questions, please address them to me. Thank you so much, guys.